Hey everybody, on today's videos we are going to help you to set up all the environment and the tools that you require to use the Hi-Fi core on ADAU 1860. So first of all, before we go into the tools, I would like to let you know that this is a web page that it is available on the ADI website. I will leave the link on the description that more or less shows you everything that you need to use 1860. Okay, so we have the hardware requirements, the software requirements, and what we are going to focus today, it's going to be the Hi-Fi 3Z core programming. So what we need, it will be the SDK. Okay, Xtensa Xplorer. This is the cadence GUI that we are using to program the Hi-Fi core. You can use your own GUI if you like more something like Visual Studio Code. That's not a problem, but then you need to configure everything. On Xtensa Xplorer, everything is already configured, so at least for me, it's much easier. You will need a cadence license. This is something that you need because we are programming the Hi-Fi core, but don't worry, you can get it on this web page. I will talk to you later about this web page. So we will need ADIU 1860 core configuration. This is required to compile the code for ADIU 1860 as a target, the on-chip debug, and a memory template. So don't worry, we will cover everything and also installing the tools. So first thing that you are going to need is ADIU 1860 SDK. So you can find it in this web page, in the product page of ADIU 1860. Here, if you go to software modules, you can get the SDK. If you click here on view details, as you can see below, it will get you to the downloader for the SDK, and you need to install that. The other web page that is also mentioned a lot of time is the Tensilica Tools platform, ADIU 1860-1. So this goes into here. You need to log, and I'm gonna log right now. Okay, so now I already log in, and this is the what we have here on the ADI 1860 Tensilica Tools web page. We have the link for the product page on the ADI website. This is the FAQ page that I was showing you before. This is linking to the Nature DSP library for the Hi-Fi 3Z core. This is developed by Cadence. And finally, we have all the development tools that we require. So if we click here, you will see everything that you need, the IDE for Windows, the core configuration for Linux and for Windows, the build tools, and the on-chip debug for Linux and Windows. Finally, we will have here the license. So as it mentions here, if you're unable to download, you might need to request access. So please click here and request access for those downloads. So when you click, you will need to accept the license agreement. And after that, you need also to accept the statement of intended use of export control. And after that, it will start to download the tools. So I already have all the tools downloaded. So what I'm gonna do, I'm gonna just install everything, and when I have it installed, I will start configuring it. Okay, so now I already installed the Xtensa Xplorer IDE. And as you can see, I just generate a workspace that it is called Workspace 2. You can call it whatever you want. And here there is already some active configurations. So the one that we are going to use is this one. I already have it installed because I have several workspace, but I'm gonna follow also the steps to install everything. If you are getting lost, don't worry. All the steps are not only here. If I go back to this page, there is this document here that it says installing tools for Xtensa Xplorer. It's on the FAQ. So, for instance, you have it here, installing tools for Xtensa Xplorer, or this one. Basically, what I'm gonna do, I'm gonna follow this procedure. So, this is assuming that you already have installed everything. It's mentioning where you can get the Tensilica tools, all you need. So everything is here. If there is some step that I'm missing or something you don't follow me, you can follow this guide. Going back here, so first thing will be installing configuration. At this moment, we are going to use this one, but we are going to install it. So I'm going to click on New Xtensa Configuration, and I'm going to say create a new build from downloaded bundle as the new configuration. Clicking on Next. I'm going to browse. And here on video training, there are some other folders that I already have with code examples that I will go later. So we need to change the extension of the file to Win32 released. And we have it here. So we click on open, add build, and now we have it. We click on finish. Okay, it's complaining that I already have it. Anyway, I'm gonna click on yes and start extracting the core configuration. So this will take a few minutes. Take it easy. And now we have here this configuration that we're going to use. But now the problem is that we do not have any active project. So the first thing I'm going to do, I'm gonna import some project, and it's going to be easy. Here, if you go to the main FAQ page, if you go to the bottom, it says example code. Okay, so we have some example code: audio path API, DMA FIFO, fast DSP and IRQ, and sample by sample demo. So we have these examples. If you click it there, for instance, I don't know, ADI audio path API, and I click it. So here we will have the example code, audio path API, and this is the I'm disclaiming, okay, this is the version that I was using. I was using the SDK 3.3.1. I don't know if maybe when you see this video, we are using different SDK version, and we are using 2022 build tools and core configuration. So I'm just stating what are the versions that I'm using in case that there is any problem in the future. With these versions, everything should work. And you have everything here, but most important, this is just the code because the example is really simple, but you have also here the project to download. So going back to Xtensa Xplorer, what I'm gonna click is in import. So I would say something like import new general existing projects into workspace, and I need to select the root directory. The directory is wherever you download all the code. So in my case, I download everything into this folder called with training. I'm gonna select this folder, and when I do this, it's just checking all the 4 projects that are already there. So what I'm gonna do, I'm gonna click on copy projects into workspace. Okay, and that's all. I click on finish, and everything is getting copied. Okay, but before going deep into the code, I would like to review first what it is included on the Lark SDK. So I'm just bringing this folder here. So this is the default pod for the SDK. And there are 2 documents. This is the Xtensa Windows Tools Quick Start Guide. This is similar to what I'm following, but I think it's out of date. And I would like to see firmware SDK user guide because I think this is a pretty nice document that it covers. This is a pretty nice document that it covers a lot of things, and it will be nice to take a look. So it covers all the SDK and the different peripherals. So you can see the architecture, you can see more details about how to configure the different peripherals, the DMA, the FIFO. There are really nice charts. For instance, this chart here, it explains really well what are the different power domains. So you have the always on power domain with the register map, the reset control, the PLL update control. We have the ADP, the audio data path power domain with the data sync, the FFS, RAM number 2, decimators, fast DSP, tip mics, ADC, and then we have the SoC power domain. So this is the main power domain for the Hi-Fi core. So for instance, imagine that our application is really simple and we just need the fast DSP. We do not need the Hi-Fi core at all. We can just power off the SoC power domain, and this will keep working perfectly nice and you will save power. This chart here, this matrix, so this matrix explains what could be the data flow, for instance, from the ADC. We can send data to the synchronous sample rate converter output, to the serial ports, to the decimator, to the interpolators, to the DAC. We just have one DAC, but we can send directly to the DAC data from the ADC, the asynchronous sample rate converter, the digital microphones, the fast DSP, the interpolator. So this is a matrix with the audio path that it is available. This chart here, I really like it because it explains how it works, the data and what is the audio flows. So we have here the ADP, which are basically the fast DSP, the interpolator, decimators, ADC. But if we want to use the Hi-Fi core to process data, which I guess it is the normal thing, we need to move that data to the SoC. The SoC is the Hi-Fi 3Z. So in order to do that, we need the data sync. We use the data sync to move the data from the ADCs, the mics, fast DSP, the interpolator, the decimator, the serial ports to the Hi-Fi. And we can do it into three different ways. We can use the TIE interface that goes sample by sample, or we can use the DMA controller and the FIFO SRAM controller. So in that case, we can move the data block based. So there are examples that helps you to configure the FIFO SRAM, the DMA controller, also the sample by sample, the TI interface. This is a really nice document. For instance, if I go and look for DMA lark only, you can see a more detailed explanation about how to use it, what are the different configurations available. If you want to configure it is in a ping pong, so the different modes, basic, ping pong, auto request. So more or less everything is here. Explain a little bit. Now that we have configured the Xtensa Explorer, at least more or less, next step will be to take a look into the code, but this is not going to happen in this video. This will happen in the following videos. So take a look to the channel